The thing that we are doing now is recording, and you can see in the video on the YouTube again what you want. Okay. Don't interrupt me. Pay attention. Okay. Entonces now, last time we start doing that problem, and we are doing something. Only the factor 4. And the factor 4 was, remember, 4, no from. Factor 4 is your factorization, the polynomial at the top, I did the last class, is 2x minus 5 and x plus 1. And unfortunately, the denominator part is impossible. It's impossible factorization because I explained, remember, get the difference of a square, binomial, difference of a square, yes, but the sum, no. I don't understand very well if you know the reason or no. Okay, the formulas in the binomial part, a squared minus b squared, the classical formula, a plus b times a minus b. This is factorization. However, unfortunately, a plus b squared, impossible to do the factorization because it's prime expression. Okay, super. What is the next step? Compute the y and z. To compute the y and z, you order the function is 0. What function? The factor 4 or the original? Both. Either way. The way you prefer. I prefer the original because you replace x for 0. That part is gone, that part is gone, that part is gone. No, it's 0, it's 0, it's 0. So that my answer is in the top -5 over 1. Okay, so now my famous point is the point 0, -5. This is the y-intercept. This is the point when this curve crosses the y-axis. Okay? For finding the x-intercept, it's different. Formula is you put a function, the original function equal to 0. Que es sinónimo to say that the top part is 0. Or much better, at least for me, is using the factor form because it's already factorization. To say for solving this quadratic equation, for me it's super easy. You separate 1 by 1 factor equal to 0, or the second factor is equal to 0. Okay, you have two linear equations in that case. 2x equal 5 divided by 2, x is equal 5 over 2. The second is x equal -1. So we have two x-intercept. It's the point 5 over 2, 0, or in decimal if you want, because it's much better to plot. It's 2.5. 2.5 in decimal is 5 over 2, 0, and -1, 0. Okay, we have 1, 2, 3 points. Perfect. No hole, by the way, no hole. Wow, how do you know no hole? Because there are no factors that cancel out. No hole. Okay. What's the next step? Verica acid. Verica acid. Verica acid, remember, you take the expression in the denominator equal to 0. This is the formula. In this case, Q is x squared plus 1. Okay, you say, wow, it's primary. What is the reason it's primary? The reason it's primary because the solution for this equation is imaginary or complex. In other words, don't exist in the real field. Okay, let me prove quickly. To seek x plus, immediately is complex or imaginary. X squared is equal to -1. Apply square root both sides. X is equal to plus or minus I. Therefore, do not exist what? Verica acid. In this problem, we have no verica acid because the solution of the polynomial and the denominator is complex or imaginary. Now, see, the solution is real, yes, exists. Okay? Okay, now next step is horizontal. Or slant, I have no idea. Slang acid. Let me put in a chronic. Slang acid. Slang acid. Well, to analyze this, or to see that, we are doing the analysis of the degree. 2x squared minus 3x minus 5 over x squared plus 1. You see clear that the degree of this polynomial is 2, and the degree of the other polynomial at the bottom is also 2. And my question is, we have this horizontal or no? What do you think? You need to remember, guys, the rule. Remember, the rule is when the degree is the same, we have. Or when the degree of the polynomial at the bottom, denominator, is greater than, que es especial. Pero this is not special, this is regular because it's the same degree. This is the same degree. Same degree. The answer is yes. We have what? Horizontal acid. And el no, because you have horizontal, we have nothing. Where? And the next question. Well, add the division of this coefficient is 2, and this coefficient is invisible 1, is add y equal to. This is my horizontal acid. Okay, super. One more thing. Well. Let me try to see if the curve crosses or not this horizontal. How do you determine that? Well, easy. You take the original expression. And you enforce it to be 2. So the y exceeds one x value such that the y value of the original is equal to the y of the asymptote. I don't know. Let me try. Cross multiplication. This and this, this and that. So it's 2x squared minus 3x minus 5 times 1, stay the same, is equal to times x squared plus 1. This triggers the property to remove the parentheses. Okay, 2x squared plus 2. Now I can see, okay, that part is cancelled out. 2x squared and 2x squared. And stay alive, minus 3x minus 5 equal to linear equation. Nice. So minus 3x is equal to plus 5 is 7. Divided by negative 3 both sides. X is equal negative 7 over 3. Okay, if you want to express it approximately, you know, en décima es negative 2.3 repeated. 2.3. Okay, so my point, my famous point that I'm looking for is the point in which the curve crosses the horizontal axis, is the point negative 2.3 repeated, whatever, comma 2, because 2 is the y value of the horizontal axis. Okay, super. So we have how many points in total? We have 1, 2, 3, 4 points, including the new point, is the point in which the curve crosses the horizontal azimuth. Remember, we have no vertical. No, unfortunately. Well, I like vertical, but we have no. And what about symmetry? Symmetry is obvious que it's no symmetry. Why? How do you know that? Symmetry, you make a reflection. And let's see, surprise, what's going on. Symmetry, analysis. Okay, symmetry is you are doing reflection. You replace x for negative x. And let's see what's going on. 2 negative x squared minus 3 negative x minus 5 divided by negative x squared plus 1. Well, I know. Okay, when it's a square, it stay positive. It's 2x squared. Nice. But this is double negative become positive. Minus 5 over x squared. When you compare this new expression and the original, I can see, wow, look like similar, but no, not exactly the same. Entonces, obviously not even. Even is when it's the same. Even is when you have the same. No, no. And opposite sign, no. Not totally opposite sign. Some sign stay the same, and some sign change. Entonces es no even nor odd is equivalent to say neither. And neither we have no symmetry. Therefore, when you plot in the negative part, the positive part is completely different. Not symmetric. No symmetry. They are not symmetry. And we have now additional point. How many points? Well, I have no idea. I put in my paper 3 points. How you select what point is important? Well, what point is important? Look, I put my all real number line, infinity positive, infinity negative. The point I have in my hand are the x-intercept, que es 2.5, this is 0, 1, 2, 3, 2.5 is here, 2.5, I know que es 2.5, look here, and negative 1. Negative 1 is here, negative 1. Entonces you select arbitrary, for example, 1 point inside this interval. I select in my paper positive 1 here. I select in my paper 5. Could be 3, 4, 5. I select 5 because I want. There are no special reason. And negative 2 and negative 3. I select negative 3. This is the 3 point I select. Negative 3, 1, and 5. I'm plugging in. Plugging in where? In the region. In the region. In the region, you evaluate G and 1. The answer is negative 3. Therefore, the point is the point 1, negative 3. Okay, this is just plugging in and using the calculator. I don't want to explain anything down. You evaluate N5, and the answer is 30 over 26. I don't know, you reduce lowest term a little bit. 15 over 13, 15 over 13. Okay, and decimal is approximately 1.15. And the point is the point 5, 1.15. Another point. And G evaluate N minus 3 is 22 over 10. And lowest term is 11 over 5. Okay, and decimal is approximate. No, approximate. It's equal 2.2. And the point is the point negative 3, 2.2. Here we have 1, 2, 3, 4, 5, 6, and 7 point. We have the horizontal axis. Unfortunately, we have no horizontal, vertical, sorry, horizontal yes, at y equal 2. And we try to construct the graph. To do fast, I want to show you the graph idea in decimals. Okay, in decimals, let me see that. Okay, where is this? Supposed to be here. Okay. Wait a second. Okay, there you go. Okay. Switching to decimals. So, what is the name of the stake that you are doing? Well, okay. I explain the name, don't worry. Wait. So this is the decimals. Bang. Okay, look at that. Well, this is the graphic. I put in blue color. Look at that, the graphic. The point I plot in green color was the excellent set negative 1,0, 2.5,0, and 0, negative 5. This is the in green I condensing the information for the intercept, y-intercept and x-intercept. In black color, okay, she asked me the name, is the famous point que no necessarily exists, in which the curve in blue color crosses the horizontal axis. Okay, the name is find the point, the hypothetical point where the curve crosses the horizontal axis. And finally, in red color, I condensing the 3 points I select 1, 5, and negative 3. I plot that, boom. And when you see the curve, our function touch, cross it, any point, passing through any point, that means we are doing super well. Any question? That answer your question, miss? Of the name of this step? Okay, super Clifford. Mr. Holmes. Okay, today we start new section. Okay, today we start new section. Okay, it's about polynomial. Sorry, do you see the whiteboard or no? I always make a mistake. Now let me see. Yeah, there you go. Boom. Boom. Do you see or not? Polynomial. And rational inequality. Wow. Inequality. Inequalities in plural. So we're solving now a new kind of inequality you never see before in your life, que es la que non-linear. So we're solving, when you compute domain, something, you solve a linear, que es super easy. But this is non-linear, entonces it's a little bit more complicated. We have two cases, que es polynomial and rational. Let's do a polynomial first, que es easier, and finally rational. Okay, example one. Look at that. In example one, we have x cubic plus 2x squared minus 3x greater than 0. This is my inequality. Non-linear because, you know, you are familiar with the linear 2x plus 3 greater than either 5. You solve it. This is linear. No. Forget about linear for a moment. Non-linear. Now, the procedure is a little bit different. The procedure, guys, pay attention, please. It's a combination, some algebra. In one moment, we are doing one graph. No graph is a number line to indicate something. And finally, we finish with the table to summarize everything. Okay? Let's do it. So the first thing is factor out. Factor completed our polynomial and the left hand side. We have left hand side. Look, this is the left hand side of our inequality. At the right hand side, you try always must be 0. Always. Yeah, in this example, it's already 0. Nice. I like that. However, in the other problem you see with me now, no. So now you factor out. You factor out the polynomial. I saw that the GCF is x because every term contains x. X cubic, x squared, x to the 1. The GCF is 1x. And we have x squared plus 2x minus 3 greater than 0. And that's it. No. We can factorization, trinomial factorization. So the GCF stay here, bring down. Yeah, open two new parentheses. You put the name of the verb of this x. And the combination in that case is 3 and 1. Because 3 times 1 is 3, and 3 minus 1 is 2. And the sign corresponding in this number is positive and negative. Okay? Entonces, I enclose in the box this new inequality. This is not new, it's the same. It's equivalent to the original, but more understandable, more accessible to get the solution. Okay, this is important step. I want to see any test. Factorization, right hand side 0, good. What is the second step? Well, the second step is write again the equation, the inequality, sorry, but like an equation, no inequality, like an equation, equal sign. You say, Professor, no, but the original is not equal. I agree, I know. But this is auxiliary tools. It helps me to understand the problem. You solve this equation. It's super easy. Each factor is 0. X is 0. X plus 3 is 0. That means x is minus 3. And the last factor is x plus minus 1 is equal also to 0. X is equal 1. And let me copy here. X equals 0. No, this in column like that, much better for me. And this guy is important, is called critical. Critical what? Critical value. Or just CB critical value. So far we call it, find the CB, and everyone knows it's critical value. And the critical value is using now to. Now we finish temporarily the algebra part. We are doing the sketch, the graphic part. But the graphic part is super easy. All right, you put it along the line, the horizontal line, like that, 0 degree. And this horizontal line represents all real number. From negative infinity to positive infinity. And using the critical value, we are doing partition. What means partition? Well, partition is you split the line in different for 0, for 1, for negative 3, negative 1, negative 2, negative 3. And you have, in that moment, you have 3 critical value, and when you split the number line using the critical value, you have 4 intervals. 4 intervals. What interval? This interval, this interval, this interval, and this interval. Okay? And the solution is, I don't know, at least 1 interval. Sometimes 2 intervals. But I have no idea. So to have idea, you select totally arbitrary, totally arbitrary. Some testing point. It's another concept. Testing point. Testing point is super important. Critical value, testing point. You select testing point inside each interval. Suppose in the first interval I select, let me use another color, negative 4. Suppose que another student select no negative 4, negative 5, or negative 6, or negative whatever, negative 100, the answer doesn't change because you select different. Because it's the same behavior in this interval. Suppose in my paper I select negative 1 here. There's one guy can represent this interval. This interval gets small, I select 1/2, positive half. And here I select maybe 2, or maybe 3, or maybe 4, or maybe 6. This is the testing point. This is what is application testing point. Well. To analyze this, there are many ways. However, I prefer do this table. I highly recommend to my student. I want to see in the test this table. And the table have different columns and different rows. And just in the first column we have TP. What means TP? TP is testing point. And you put the arbitrary testing point that we are using, que es -4, -1, es 1/2, y es 2. Okay. And every testing point give me a row. 1 row, 2 row, 3 row, 4 row. What about column? Well, the column is exactly the same of the factor that we have in the original problem. And the original problem we have x. Look, x. Where come from this x? This factor. We have another factor that is x plus 3. Que es that factor. Okay. One more. Well, we have x minus 1. Is the last factor. And finally, you create another additional column that I call total. Why total? Because in the total column, I summarize all information that we need. And this is my famous table that I want to see in the test. I want to see in the test this graph, this line, number line. I want to see the table. Like that. When I grade this test, when I grade this question in the test, see, I don't see table, I don't see line, 0. No, I don't understand anything. Okay, now you plug it in. This is the important moment, crucial moment. You plug it in. Plugging in what? You plugging in this testing point into the each expression. For example, -4 here and negative. So I don't care the value. The value is totally irrelevant. The important information is the sign. Si es -4, well, you can put -4 if you want. But I don't care the value. I care the sign. It's negative. -4 here. Look, -4. Plugging in here. Plus 3 is -1. Entonces, okay, I understand que es negative. You put negative here. And -4 and -1 together is -5. And -5 is also negative. And remember, this sign is the sign of each factor separately. However, when you integrate, you have negative times negative times negative, is negative total sign. I am closing the circle because this is important information. Do you follow me? Do you follow me? Do you follow me? Do you follow me? Eso, bueno. Follow me, follow me. You say yes, okay, I trust you, yes. Do you follow me? This is easy, this look like a game. For me, it's easy. Let's continue. I know it's too long, but it's easy. -1 now. -1 is obvious que es negative, bang. -1 is positive, because -1 plus 3 is positive too. And -1 is negative again, 2 negative. And that is super easy to understand. When you have 3 negative, bang, 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 the answer is negative. When you have two negative, suppose like that, it's positive. Because when you have even number of negative, it's positive. When you have odd number of negative, it's negative. This is the rule, but it's logical, no? It's multiplication. This is plus. Okay, 1/2 is positive. 1/2 is positive here. 1/2 here is negative. And we have 1 negative and negative. And 2 is positive. And 2 plus 3 is positive. And 2 minus 1 is positive. Therefore, the answer is positive. I finish my famous test. I finish. Okay, so what is the answer? Well, the answer is easy. Look, we come back at the beginning. In the beginning, we have that inequality. And this inequality, look at that, this is important detail. This inequality is greater than 0. And greater than 0 means positive. So the only row when you testing using the testing point, give me the true is the positive guy. Okay, so this is positive, this is correct, and this is correct, and this is incorrect because it's negative, and this is incorrect. Entonces, I, just in case, to make sure que everything is okay, I highlight that interval gets true. It's this interval in which the testing point -1, look, give me the true. And another point is testing gets 2, give me the true. Okay. And what happened with the endpoint? This is important detail. Is parenthesis, parenthesis, and parenthesis. Why? Why no bracket? Because the point -3, 0, and 1 is not included inside the solution, because -3, 0, and 1 is solution of the equation, not solution of the inequality. Ah, well, professor, suppose another example in which you have equal sign here, or entonces it's different. I promise in the second example you see that, but not in this. I don't want to complicate your life now. This is easy so far. So what is my final answer? What is my final answer expressed in interval notation? Final answer. What is my final answer? My final answer is the solution of this inequality is the interval from -3 to 0 union 1 to infinity. End the story. Final answer. Any question? It's exactly the interval I highlight in green color on the number line. Any question, guys? It's easy. Easy or hard? I know it's too long. This is not the point. Remember, this is called algebra. This is not inequality algebra. Okay, the problem here is not easy. It's 2 plus 2. No. It's hard. I know it's hard. And this is just the beginning. This is the elementary inequality example. I want to complicate more this. Okay? Any question? Any question? I want to hear a question. Professor, I don't understand anything. Okay. Inequality. Non-linear inequality. Polynomial or rational? When we study now polynomial. Rational, no yet. Okay, let's move on to another example, a little bit more different. We can choose any point, yeah. Any point in the bar, yeah. Okay. Let me summarize. Good question. When you have the critical value in your hand, you take the number line and you make a partition. Bam. So now we have 4, 5, I don't know, depending on the problem, interval. And you select completely arbitrary testing point inside. You pick, you choose arbitrary testing point. And you evaluate in the factor and give me the signs que corresponde for this guy. Entonces, pass the test or fail the test. They have 2 possibilities, no? Si pass, entonces you include inside the solution. Si fail, no. Okay? Example 2 now. Example 2 is a little bit on the understand. Okay. Dylan. Okay, look at that. Look at Dylan. This is another complicated, not complicated, weird. Okay? This example bring me 1, 2, and 3 new situation. Okay. Situation number 1. Professor, right hand side is no 0. Okay? No problem, I create that. You move everything to the left. And now we have 0 in the right hand side. This is 0 is super important. To start any problem, we need 0. What is the reason that we need 0? So right hand side mandatory must be 0. What is the reason? Because when you create the table give me que es positive o negative. Si es positive es above 0. Y si es negative es below 0. So the level 0 is super important to comparison. It's a reference level. Okay? To compare. So this 0 is important. Another example, you have no 0, you have, suppose you have this x squared minus 4x squared greater than or equal to 2. No good. You move everything to the left because I need 0 on the right hand side. Correct? Okay. Now, this is the moment to make a factorization. In this case, GCF is x squared. But you have 4 and 2 is 2. X squared minus 4 greater than or equal to 0. I think no. I have a differences of a square in the second parenthesis. Look, it's x squared, open two parentheses, binomial factorization, difference of a square is xx, 2, plus or minus. Doesn't matter what is plus and what is minus. Yeah, enclose, when you finish the factorization, this is a super important moment, and you put this information inside the box to emphasize it's important. Okay, it's not completely different, it's equivalent to the original, but in the original, I don't understand anything. In this, I don't understand anything. However, in this new one, it's clear for me because left hand side we have different factors, and right hand side 0. Nice, we start. Find out the critical value. CB, find the critical value. The critical value is easy because you take the expression and you enforce it to be 0. Equal to 0. Bueno, entonces x squared is 0. It means x is 0. Because the square root 0 is 0. No? X plus 2 is also 0. X is minus 2. And x minus 2 equal to 0. X is negative, positive 2. And this is the collection of the critical value that I am using to make a partition of the famous all real number line. Okay, this is my famous all real number line. But positive infinity, negative 0, always in the middle. And 0 is coincident with the critical value. Partition here. Positive 2 and negative 2. 1 and 2. And negative 2. This is my 3 partition. So we define again 4 interval. The interval, and the interval. So in this interval, you select totally arbitrary testing point. I can ask you what testing point. No, either one. So for example, in this interval, I pick negative 2. In this interval in between negative 2 and 0, I pick negative 1. You can pick either, but no decimal. Horrible. Confusing. No. Whole number, negative 1, positive 1 in that case, and positive 3, why no? Or 4 or 5, 6, 7, it doesn't matter. Okay, when you pick that, this is a crucial moment in which you build a table. My famous table. Remember, the organization for the table is always the same. You have one column, get TP. In this column TP, you write the testimony. Negative 3, negative 1, positive 1, and positive 3. Okay? And this Testing point represent a row. Okay. Now, in the column would be the factors. The factors, x squared. Look, that factor, x squared, x plus 2, and x minus 2. And don't forget the important column, que es the last column, que es the total column. Total column. Okay, ready. Entonces now I bring intentionally this example because this example give me some new information. The first new information is that don't expect that the right hand side is 0 automatically after the original problem. Number one. Number two new que bring me this example. Pay attention, it's important. The first column, que is the column of the x squared, regardless que the number is positive or is negative, always should be positive. Yes or no? Why? Because negative 3 squared is 90. Positive. It doesn't matter if the number is positive or negative. When you square, become positive. And remember, the important information to select true or false and the total depending only on the negative value, not the positive value. Okay, remember, so you have positive, negative, positive, because it's too negative. And what happens is, professor, not important. The positive is not important. If it's not important, you can omit that part. How do you know that you can omit that part? Because any exponent gets raised to the even exponent, when you square, it's positive. So now you ignore, totally delete this fact. This is not important, irrelevant. And you focus on the important part, que is x plus 2 and x minus 2. Suppose another more complicated example you have. I want to explain in detail in the next example. Suppose you have some factor, and this is 2, and this is 3, and this is 4. They down equal to 0. You can ignore this, and you can ignore this. And you focus only on the odd exponent. Because I know that in the even exponent, always is positive and doesn't affect my answer. The only thing affect my answer is the negative and the analysis. Okay, let's move on to the factor, to the negative 3. When you plug it in here, it's negative. And negative because negative 3 plus 2, no? Negative 3 plug it in here. I suppose you understand this, no? Because another day, and I explained this in Broward College. Some students say, no, professor, I understand everything except I welcome from this mind. So you don't understand anything. This is the most important moment. This is the most important part. Okay, you plug it in one by one, testing point into these factors. Because now this is negative 3 plus 2 and negative 1. So you put negative. And this is negative 3 and negative 2 and negative 5 and negative. Double negative point. I put this in one circle because I want to emphasize that this is important information. This is the information can help me to make decision. And this is completely partial, intermediate solution. Negative 1 here and negative 1 plus 2 is positive. And negative 1, negative 2, and negative 3 is negative. The answer is negative. And 1 is positive because 1 plus 2 is 3. And 1 minus 2 is negative. N is negative. And 3 is positive. And 3 plus 2 is 1. Okay, we come back to the beginning, the original expression, the original inequality. Look, again we have that symbol greater than or equal to 0. The one more time is repeated. Okay, not always happen. Okay, the true value or the true interval is the interval is select by the positive, because suppose another inequality, can I change the problem, is less than or equal to 0, and those the true guy is a negative. Do you understand this or no? Pero no, in this case, no. In this case, the true is the positive. The true is the positive. This is true. This is true. This is false. This is false. Not necessarily indicate the false. Indicate the true is important. And so now my -3 testing point passed the test. And our interval, remember, -3 was one totally arbitrary crazy point I select inside the interval. But my actual interval is extending from -infinity to 2, because the boundary que separate the first interval and the second is -2. -1 failed, no good. +1 failed, no good. 3 passed. Okay? This is my graphic solution. But I want to express it in interval notation always. Okay? Okay, let me try. We have a new thing in this example now. Another new thing is, look what happened with the endpoint. In the previous example, in example 1, you put parenthesis. In this case, no. Why not? Because this inequality is not a strict inequality. It's a combination. Inequality and equation. Look, is greater than or equal. This is inequality and this is equation. Therefore, the solution of this problem, que is our problem, is the solution for the inequality plus the solution for the equation. The solution for the inequality, que está apart, is exactly the thing I highlight here in green color. The solution of the equation, I have here, is 0, positive 2 and negative 2. Entonces it's easy. I put here, -2 is a bracket, positive 2 is a bracket. Bracket, remember, means que include the endpoint. And 0 also que represent one isolated point in the middle of the nothing. Okay? Okay, the solution, okay, this is the most important or the most complicated part to understand, at least for me, no? Okay, this inequality is different to the first one. In the first one, to be solving, in the example 1, we have one symbol, only one, greater than. This is pure inequality. And this is not pure inequality. It's a compound. It's not compound, it's a combination. Combination, inequality, and equation. The solution for the inequality was easy. We highlight in green color. Entonces you complementa with the solution for the equation. The solution for the equation is the critical value, que es -2, +2, and 0. What is the traditional way to indicate that? Well, in the endpoint you put the bracket. In the point you put the point, the circle full, the circle closed, similar to the solution for the equation. So what is my final answer in interval? Final answer, guys. This is an important moment. Final answer. The final answer is from -infinity, comma, -2, bracket, and descending order. And the order is not important. You put in any order, but I highlight in this order, so from left to right. Union 0, que 0 is one isolated point. I indicate this symbol, similar to the solution for the equation. When you solve the equation, you say the solution for the equation is 1, 2, 3. 1, 2, 3. You separate by a comma the value and indicate using curly bracket like that. This is the same idea. Union bracket 2, comma, infinity. This is my final answer. Okay, let me summarize this example. It's important, extremely important. In this example, you see several new things. Number 1, new thing we saw was, okay, in the original problem, we have no right-hand side 0. I need to create that part. that part. In this example, we discovered the one column we can delete. And the reason is because contain exponent given and always a positive. In this example, we saw also what's going on when you have inequality and equation together. Okay, you consider it the endpoint and maybe another point. In this case, 0, because completely isolated point. Super. The thing I want to clarify a little bit, is when you delete or when you don't delete. It's because I say, no, for sure, 100%, when the exponent is even, you delete. No. It's not exactly the same. I want to explain one more detail behind that situation. So far, any question? Any question? Come on. Are you totally lost? You don't understand anything? Or everything is clear? I know that you need to practice. That is the reason that we have homework, no? By the way, nobody go yesterday in the tutor service. I assisted another student, not my students. Because I suppose that my students are a genius and my students have no problem, no? I do everything clear, perfect, no problem. No, you're laughing. This is my job, okay? I like to help you, okay? The problem is that you need to dedicate time. In mathematics time, mathematics practice. You sit with me. I understand very well. You explain very well. I explain very well, but you don't know anything, right? That you need to practice. You need to face with a new situation, and you need to solve it. When you're stuck, it's normally because you are students. Yeah, I can help. Okay, you email me. Because one possibility. Suppose you are a busy guy. You have 5 part-time, 2 part-time, and 5 children. Okay, I understand. But you email me. You might send me the screenshot of the question I want to solve. Yeah, I solve it. I send the solution back. Okay, you have no time to go to the total survey. Okay, I understand. No 5 point extra. 5 point extra, the only student can go to this. So when you get inside and you get time with me, you have 5 point extra. I don't know if I am clear or I am confused. Or you don't understand the. Go ahead.
Can you explain one more
time?
Can you explain one more time? Like for our testing points, when they come out positive for the total, can you explain one more time? Like depending on the sign in the beginning, why?
Yeah. Of course. Okay, in this specific example, my inequality is, do you see greater than or equal to 0? What means to be greater than or equal to 0? It's non-negative. Non-negative is the meaning of this. And non-negative is close. So the only guy, so of course, in the total column, que es the last column, que is the most important column, maybe using another color, is the column that you see when it's positive. Mr. Holmes, and you understand where come from that positive or no?
Yes.
Okay, this is important. Okay, your question is, well, okay. When you see greater than, the true guy is the positive. And what is the statement for the false? You want to see like that? It's much better. And false, that means it don't belong to the solution. This piece don't belong. So it's equivalent to say, in the another way, some people, there are many ways to do this. You say this is true, this is false, this is false also, and this is true. That is a reason I highlight in green color the truth map. Got it?
Got it.
Excellent. Okay, let me complicate more your life. Let me explain in detail now when you delete actually, totally, or no. This is called a special case. Special cases. And the test, I promise, this is important part, guy. In the test, you can see 3 questions of this kind of inequality. And one of them is special. So what you understand is special. It's special exactly when you have exponent even. Suppose this case, x minus 5 times x minus 4 square greater than or equal to 0. To say, so wow, look, this exponent is 2, it's even. So you completely delete this guy. And this is equivalent to say x minus 5 is greater than or equal to 0. This is a linear inequality, easy, exactly the same we solving in the chapter 1. X is greater than 5. Well, so you want to express it, this solution in the number line. Well, this is 0, 1, 2, 3, 4, 5. It's greater than, it's to the left, to the right. Include, of course, 5 bracket. Okay, so in other words, so you want to express it. Remember, in the test, always I want you express any answer in interval notation. It's bracket 5, comma infinity. Okay, no new. This is the first special case. Suppose now, look, this example. Entonces, what is the reason I delete this? Under the consideration that this is always positive. And the positive doesn't affect my inequality. It's completely irrelevant. But what's going on is you have, for example, x minus 3 and x minus 4 square, similar, very, very similar, but only greater than 0. This is different. What is the difference? The difference is that this sign is greater than or equal. Okay, it's the combination inequality and equation, and this is just inequality. And what to explain is different. You delete, but you delete partial. What means to be delete partial? Delete. This is complete delete. Here, I ignore. I don't care. In this case, no. It's partial. Why? Why is partial? Because this is equivalent. Look. This is equivalent to write x minus 3. Perfect. Good. Greater than 0. But you consider it and one condition is x not 4. It's like a whole. It's like a whole. Why? Why? I need to understand this. Well, because 4 and 4 happens something weird. Look, suppose I plug in 4 and they're reaching an equality. 4 minus 3, 4 minus 4 is square greater than 0. 4 minus 3 is 1. 4 minus 4 is 0. 0 squared is 0. And 1 times 0 is 0. And 0 is not greater than 0. This is a contradiction. Therefore, I need to exclude the solution. I need to exclude the solution. So it's easy. It's no, you don't need to understand the idea behind this. It's mechanical. You are doing like that. When you see that my inequality have no equal, entonces you consider like a whole. Index in the factor que contain even exponent. In this case, no, you totally ignore. Okay, doesn't affect. So what is my final answer here? Well, my final answer here in this problem is, this is my overall number line, infinity positive, infinity negative, 0 in the middle. Okay, this is x greater than 3, no? When you solve for x, 1, 2, 3. So it's 3 but greater than, so it's to the right again. Okay, good. No include 3. No. It's no bracket like that. It's parenthesis. But in 4, we have a hole. Pero hole, no, I did wrong. All a hole. Like that. Okay, hole. Okay, so now how you represent the answer in interval notation? Well, es paréntesis 3,4, it's a 4. Paréntesis union 4,3. So basically, it's all whole thing except in 4 we have a hole. Okay, this is a hole. Do you understand this or no? Do you understand this or no? Eso, bueno. Okay, I bring another example. You help me. You help me. And let's do it together. One more example, and you help me now. Look. Example 3. Example 3 is x minus 5, x minus 4 squared, less than 0. Okay, I can see immediately. Oh, it's special. Why is it special? Because we have some factor that contain exponent even. But you delete or partial delete? Delete or partial? Delete. What do you think? Partial. Very well. No delete. Because there's no equal here. When it's equal, you delete totally. So this statement is equivalent, this is inequality, sorry, is equivalent to say x minus 5 less than 0, and you consider a whole in 4, similar to this. And you solve for x here, less than 5. Well, pero the professor wants the answer in interval notation, like that. So to understand much better, I create my order number line. 0 here, 1, 2, 3, 4, and 5. And 5, but 5 is to the left, no? Because it's less than. It's less than, that part, less than. But I know, okay, 4, we have a hole here. We have a hole. And 4, we have a hole. Here we have a hole. And 4, we have a hole. And in 5, never touch 5 because we have no equal. And the symbolic way to represent this idea is using parentheses. Espérate, wait. Parentheses not in black color. Parentheses in yellow color. So what is my solution? My solution is from negative infinity, comma, 4, no include 4, because 4 is a whole, union, basically we have 2 pieces, union, 4, 5, end the story. This is the answer. Do you understand this or no? Do you understand this or no? Super. Okay, guys, this is easy. Of course, we need practice. I promise. In the review package, you see more problem. Very similar to the problem you face in the test on paper, no? But in the test online, que saying Alex, well, I face some problem more complicated. And you need to be aware of any situation. I understand that you see that it's too far the test. The test number 3 is November 4. Well, technically, no. Maybe I changed the date. I control this. Okay, let me try now in the time that we have. Okay, would you clarify and you say the never touch? Yeah. Parenthesis. So you put the parenthesis. And 5 you put the parenthesis. Let me go back. In 5 I put the parentheses. Therefore, in the final answer, parenthesis in 5. Because in 5 don't touch. How do you know it don't touch? Because I don't see. Because I don't see equal sign here. No equal sign here, don't touch. Okay? Super. Let's move on now to the same. We are continuing doing the same, but now a little bit more complicated. Rational. Rational is the division to polynomial. It's example 3, no? Well, no, it's a 3. It's 5. No, I don't know. I don't care. The number is not important. Suppose x minus 1 and x plus 1. This is a rational inequality because of the division to polynomial, greater than or equal to 0. Well, this is already doing something. So some polynomial, do the factorization of the polynomial in the top, do the factorization of the polynomial in the bottom. Nice. I appreciate so much this help. And create the right hand side 0. Okay, so now it's fantastic. Now we are doing now the critical value directly. Critical value. But critical value, we have the critical value in the top y the critical value in the bottom, ¿no? Ajá, entonces es easy. You copy the polynomial in the top, you enforce it to be equal to 0, solution es 0 y esto. This is my couple of critical value in the top. Critical value in the numerator. And now let's do the critical value in the denominator, que es x minus 1 and x plus 1 equal to 0. Entonces now es obvio que 1 and negative 1. ¿No? This is the critical value in the denominator. Everyone follow me so far or no? Everyone follow me so far? Eso, bueno. Now what should I do? Well, number line. Using the critical value to make a partition. Okay, 0 is in the middle. Critical value of the numerator. 2. Another critical value numerator. 1. Critical value denominator. In the same category. Well, not exactly. And negative 1 is the critical value. In total, we have 1, 2, 3, 4 critical value. Therefore, we have 5 intervals. Okay, because you need to pick totally arbitrary testing point inside. For example, in this interval, I pick negative 2. It's a big interval, so we have infinity possibility. In this case, we have infinity, but no, it's a short interval. 5 testing, no? Suppose negative 1/2, it's good. Suppose positive half, it's good. Suppose 1.5 or 3/2 in fraction, and suppose 3. This is my testing point. Okay, so now the table. Testing point. 5 testing points we have. Negative 2. Negative 1/2. Positive 1/2. 3/2 and 3. Okay, super. We have special case? No. In this case, we have no special because I don't see any factor that contains exponent even. The factor in my problem, the exponent is missing, therefore I suppose que es 1. Entonces normal, linear, and entonces now I need to include everything. The factor is x, no delete. Si es x squared, yes, but x no. X minus 2, x minus 1, and x plus 1. And my famous column, last column, is the total. Let's do it. Negative 2 es obvio que es negative. Negative 2 es obvio que es negative. Negative 2 es obvio que es negative. Negative 2 is obvio que es negative because negative 2 plus 1 is negative 1. 4 negative is positive. You see that? Negative 1 is negative. Negative 1 is negative again. Negative 1 is negative. But negative 1 half, sorry, plus 1 is positive. And 3 negative is negative. 1 is positive. But this is negative because 1 half minus 2 is negative. And 1 half minus 1 is negative. And 1 half plus 1 is positive. This is positive. So 2 negative is positive. Remember, the important information to determine if it's positive or negative is analyze how many negative we have. See, the number of negative is even is positive. See, the number of negative is odd is negative. Do you understand why? It's a multiplication. It's just a multiplication. When you multiply 2 negative, it's positive. When you multiply 3 negative, multiply or divide. Okay, in this case, we are doing the combination, multiplication, and division. It's the same thing. So this is plus. This is negative, because 1.5. And this is positive, and this is positive. But negative is negative. And 3 is positive, 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 and in this case, a coincidence. And the example we are doing next class is different. Everything so far would be greater than or equal to 0. That means the true part is the positive. This is the true part. This is the false part. But you don't need to put true, false, no. You select the true, only the true. The false, I don't care, because 4 I know there's no solution. So if the testing point failed, it's because we have no solution. The true was corresponding for the testing value negative 2 is this interval. 1/2 is this interval, and 3 is this interval. Start and 2, no? Okay, and this part I highlight in yellow color represent the solution for the inequality part. Represent the solution for that part. But in this case, you have equal sign. Be careful. One new detail. The 0, so the equal sign equal to 0, is the 0 of the numerator. So this guy, this guy gets 0, and to represent the 0 of the numerator. And the 0 of the denominator is never a solution, because you know the division by 0 is undefined. So the critical value of the denominator is no important, no included, never. And the 0 of the denominator, yes, included. Well, included when you have equal. Suppose another problem, for example, erase that part. Yes, greater than only, no equal. So no include everything. No include. Because we have no equation. It's just inequality. But no. Wait, professor. Don't confuse. It's included here because it's equal. Okay, this is my original problem. Because the interpretation is equal sign, include the solution for the equation, but only for the critical value in the numerator. The critical value in the numerator, never. We include. Because it's undefined. So what is the symbolic way to indicate this idea? Well. 0 bracket, 2 bracket, 1 and negative 1 parentheses. No include. What is my final answer then? Look in the graph. Well, my final answer is then here. Final answer. Okay, is from negative infinity to negative 1, parenthesis, no bracket, union, bracket, 0,1, parenthesis, union, bracket, 2,3. End the story. This is my final answer. Any question? Wow, amazing. The time flies. But today I suppose you understand. But don't worry, guys. Your job is doing the homework. Remember, this is one secret. I don't want to. The test and the homework is similar. It's the same. I just copy. Of course, no expect the same number, but the same objective. That when you are doing the homework, you are doing automatically the test online. And also, I give you extra point. And also, I give you extra points. You go to the tutoring. One more you want. Suppose que nothing, right? Why do you bracket in one? No. This is no bracket. This is parenthesis. Sorry, see, I make a mistake. This is round. This is okay. This is no square. This is no bracket. It's parenthesis. Look. Okay, Mister.
I get that, but isn't it a whole after? Why isn't it a bracket?
And what? And one?
Yeah, after one isn't
Good question. Because one and negative one both are zero of the denominator, and the zero of the denominator never we include inside the solution. Why not? Because you know what happened. What happened when you put one here? 1 minus 1 is 0. 0 divided by 0 undefined. No, illegal, right? And negative 1 is exactly the same. Negative 1 plus 1 is 0. Okay, the 0 of the denominator never we include inside the solution because we completed out the domain. Completed out the domain. More clear now, Holmes?
Yes.
Okay, super. Okay. So now stop recording.